Assalamualaikum warahmatullahi wabarakatuh and a good day to my Honorable Malaysia Technology Expo MTE 2032 judges. My name is Associate Professor Dr. Mdihat Nabil bin Ahmad Salimi from the Faculty of Chemical Engineering Technology, University Malaysia Perlis UniMAP. Today I'm going to talk about my invention with the title of Carbon Capture by Eggshell Waste. It is also a research collaboration with Teknologi Tenaga Perlis Konsortium Sdn Bhd or TTPC. So I would like to start with the problem statement of my invention, which is global warming. Global warming can be defined as the rising of global average temperatures. The effects of global warming include less snow and ice, more droughts and wildfires, warmer oceans, and rising sea level. Carbon dioxide's invisibility is what causes global warming, meaning that the more CO2 emitted, the more of this gas will trap heat, causing global warming. In terms of total CO2 emissions in the year 2017, the transportation sector contributed the most, which was 47%. This was followed by industrial activities, which contributed another 23%. In terms of largest producers of CO2 emissions worldwide in 2017, China led the list, followed by US, India, and Russia. Basically, a country with huge populations tended to produce more CO2 emission. Shockingly, Malaysia was ranked at number 26 as the largest source of greenhouse gases in the world. Naturally, the emitted CO2 will be captured about 25% by plants and another 25% will be captured by sea. The remaining 50% of the emitted CO2 will be remain in the atmosphere. My invention is based on eggshell waste, which is used for carbon capture. Eggshell, or ES, is an emerging abundant solid waste created from various sources such as poultry, homes, restaurants, and food manufacturing industry. In Malaysia, about 642,600 tons of eggs are produced every year, and from this amount, a total of about 70,686 tons of ES waste is expected to be generated every year. This waste has potential for producing hydroxyapatite, with the chemical formula of Ca10PO46OH2, a major component found in bone and teeth. Hydroxyapatite has the big potential application for carbon capture. It is well known that carbonate ions can substitute into the hydroxyl lattice by replacing both phosphate and hydroxyl group. The image shows the phosphate and the hydroxyl group's location within the hydroxyapatite structure. The first step of my invention is to synthesize hydroxyapatite powder from eggshell waste. This is done by carrying out the mechanochemical method or by using a ball mill. The image at the bottom shows the produced hydroxyapatite powder. Secondly, is the step of converting the HAP particles into solid sorbents. Here, it is done by using a wet-based granulation process. The produced hydroxyapatite granules is shown in the image below. The hydroxyapatite granules or solid sorbent has the dimensions of a length of 3 cm, diameter of 0.5 cm, and a weight of 1 gram. And lastly, for the carbon dioxide CO2 capture analysis, it was performed in a tube furnace under a dry CO2 flow. By this analysis, the actual amount of CO2 absorbed into the hydroxyapatite granules or the solid sorbents was determined. The image at the bottom shows a tube furnace. As a result, it shows that hydroxyapatite granules absorb almost 4 times its weight in carbon dioxide or CO2. carbonate was substituted into two ionic sites of the hydroxyapatite structure, one at the phosphate sites, or known as the B-type carbonated apatite, and the other one is at the hydroxyl sites, or known as the A-type carbonated apatite. The image shows where the CO2 were absorbed into the hydroxyapatite structure, where they were absorbed at the phosphate and the hydroxyl site. In terms of novelty, this was the first reported of hydroxyapatite nanoparticles synthesized with control parameters by mechanochemical method, which produce uniform and small particle size. This is proven by the patent filing document shown here with the document number of PI 2014702579. In terms of publications, I had published some articles, some in a very reputable journals such as Powder Technology, which is a Q1 journal with impact factor of 5.134. In terms of industrial collaborator, Technology Tenaga Perlis Consortium Sdn Bhd had expressed their interest for research collaboration in terms of the applicability of the hydroxyapatite granules in absorbing carbon dioxide or CO2 produced at the power plant facility. This means it is a large-scale carbon capture by using the hydroxyapatite granules. In terms of commercialization, the carbon capture market was valued at 4.4 billion US dollar in 2018 and is projected to reach 14.2 billion US dollar by 2025. For the status of innovation, it is at technology readiness level or TRL 7, which is system prototype demonstration in operational environment. As a conclusion, Eggshell or ES is a natural waste produced in abundance yearly, which can be transformed into hydroxyapatite granules for carbon dioxide or CO2 capture application. This avoids of using synthetic chemical formulation to capture carbon dioxide CO2, which are less effective and costly. Hence, this innovation can also be termed as green invention. This innovation also supports the Sustainable Development Goals or SDGs under goal number 13, which is climate action. And lastly, eggshell is a waste largely considered as useless and is discarded mostly because it contributes to pollution. In fact, eggshell waste can be used for carbon capture and its impact is huge globally for tackling the global warming issue in many years to come. So that's all my presentation. Thank you for spending your time listening to my presentation. I hope you all have a great day. Be safe and take care. Thank you once again.